Assalamu alaikum.
We'll continue the partial derivatives. So now some exam questions I'm doing. Yesterday we have given the concept of partial derivatives. Today this class is very important because there are two reasons. One reason is it is your pending class. The second reason is the questions which I am doing now, it is examination point of view, it is important.
Okay, sir.
If u is equal to, the first question will be 1 by under the root of x square plus y square plus z square. Where the restriction is x square plus y square plus z square is not equal to 0. Because if this is 0, we cannot define u. Then we have to prove that the partial derivative of u with respect to x twice, 2 times, plus the partial derivative of u with respect to y 2 times, plus the partial derivative of u with respect to z 2 times. If you add all these values, you will get your answer will be equal to 0. This one we have to show, right? So let us moving to the solution. Whatever the basic is required for this problem, I'll give you. Here given is u is equal to square plus y square plus z square. Can I write like this? This power 1 by 2 root denominator can be also written as power minus 1 by 2. Can we write like this? Root means power
Yes,
1 by 2. If you take to the numerator, it has becomes negative. Understand?
Yes, sir. Yes, sir.
Okay, then just 1 second. Okay, so we apply the formula of x to the power of n here. What is the formula? Let me write it. Derivative of x to the power of n. What do you say? What is the formula of this? Nx power n minus 1. And we do not forget to write the inner function. That is inner function with respect to x. We apply this formula for this term. Can you tell me what is n? Abdul Bari, what is n value and what is x value? Can you tell me that?
Yes, sir. N value is minus 1 by 2. X value,
The complete value is x. That is our function.
yes.
Correct? So
Yes,
let
sir.
us differentiate this value partially with respect to x. We can differentiate for the power first of all. That is n x power n x power n minus 1. That is minus 1 by 2 minus 1. And now the next step is important. What actually we are doing? We are differentiating partially with respect to x.
Yes, sir.
Means y is a constant. Correct?
Yes, sir.
So what answer you will get as an inner function? I will get only 2x here. This is only possible value
Yes, sir.
because we are doing partially with respect to x. So when inner function will be
Yes,
doing
sir.
x square becomes 2x. These two
Yes.
must be cancelled.
Yes.
Okay, so this dou u by dou x can be written as, but minus must sign as it is. This x we can, okay, no problem. Let us be here only. X square plus y square plus z square whole to the power of minus 1 by 2 minus 1 is minus 3 by 2, and this x must be as it is. So one time differentiation with
Yes.
respect to x is done. Now another time we
Yes,
have
sir.
to do it. Okay, another time. So one more time. That is 2 by dou x of dou u by dou x. So once if you apply this formula, be careful that we are going to keep it minus sign outside. We assume this total function as u and this function as v. Okay, for your convenience, I will write it. This is our u value completely. This is our v value completely. Understand?
Okay, sir. Yes,
First
sir.
function u as it is. X square plus y square plus z square whole to the power of minus 3 by 2 as it is. Now, once if you differentiate x with respect to x, your answer will be 1 plus x as it is. Now, apply the derivative for this term. We should apply the power here first of all, n x power n minus 1
Yes.
into inner function is 2x. This bracket will be closed. Are you getting my point?
You have to add the, you have to add the inner function also, sir,
Yeah,
in this.
again inner function is 2x. Okay, now
Okay.
this two
Okay, sir.
will be cancelled. Now see what
Yes.
the second term. The second term becomes, see, I'll be doing the remaining part here. What happened to the second term? You see, this is dou square u by dou x square value we are doing. That is equal to, minus must be outside only. We don't want to disturb minus side. X square plus y square plus z square whole to the power of minus 3 by 2 also as it is. We don't want to disturb that. Into 1, it is 1 only. But now second term, plus into minus minus 3x into x square. I want to write like this. Minus 3x square into, correct? Into
Yes,
x
sir.
square plus y square plus z square whole to the power of minus 3 by 2 minus 1. Can I split like this? Minus 3 by 2 separately. Again, x square plus y square plus z square whole to the power of minus 1 separately. And then bracket close.
Yes, sir.
I'm splitting this term into two parts. Why? Why?
Okay,
Because
sir.
it is convenient to take this underlined term as a common term. This one here, and moreover, it is available here also. Can we take it common?
Yes, sir.
Very
Yes, sir, we
important
can.
question we are discussing. Be careful. I want to take minus will be there. X square plus y square plus z square whole to the power of minus 3 by 2. We are taking common. So that is open the bracket. This is already totally outside. So one left over here. Minus, okay, now 3x square will be there as it is. This total term will be outside. So what's left here? X square plus y square plus z square can be written as x square plus y square plus z square whole to the power of minus 1. I am writing in the denominator. Is that okay?
Okay. Yes, sir.
Correct? Minus of
Yes, sir.
x square plus y square plus z square. You have discussed this question in your college, I think not discussed till now.
No, sir, not discussed.
Once if it is going on in your classes, now it will be very easy for you. X square plus y square
Okay.
plus z square will be the LCM. Multiply with the 1, you will get the same thing. X square
X
plus
square
y
plus Y.
square plus z square and minus 3x square. Correct? Correct now? If you take the LCM, you will get minus 3x. So which is
Yes,
equal
sir.
to minus x square plus y square plus z square whole to the power of minus 3 by 2. What happened if you simplify this one? Can we get this term? Y square plus z square minus 2x square divided by
Yes, sir.
x square plus y square plus z square. See,
Yes, sir.
actually one part of this problem we have done. That is dou square u by dou
Dou
x
X.
square pattern. Now there is a
Yes, sir.
speciality of this pattern. What is that? You can see. First term, that is minus of x square plus y square plus z square whole to the power of minus 3 by 2 as it is. With respect to x, when we are doing now, first y square we are getting, then z square we are getting, then minus 2x square we are getting. If I am doing the
Yes, sir.
similarly, have you heard before similarly concept?
No, sir.
Similarly, I tell you. Here, no need to do the second part completely. We use
Okay.
special, this is called similarly, dou square u by dou y square is equal to minus of x square plus y square plus z square all to the power of minus 3 by 2 as it is. Now, since with respect to x, oh, sorry, here it is now y,
Y.
y, it is y,
Yes, sir.
it is y. So the
Yes, sir.
pattern will be, see, with respect to x, x came later on. So now it
Yes.
is x square plus z square minus 2y square divided by x square plus y square plus z square. Is it okay? Look at the
Yes,
pattern
sir.
and you can get the next value. We called this one as equation number 1. We called this one
Yes.
as equation number 2. Now, similarly, I want to get the value of dou square u by dou z square. That is equal to, can you tell me that? Minus x square plus y square plus z
X
square
square
whole to
plus
the
Y
power of
square
minus 3 by 2 as
minus
it
3
is.
by 2.
Now, follow the pattern.
X square. X
Yeah,
square plus
x
Y
square
square
plus y square
minus 2 Z
minus,
square.
very good, minus 2z square divided by x square plus y square plus z square. And this is called it as equation number 3. So according to my requirement, I want to add all these values. Okay, I think I should
Yes,
go
sir.
for the next page for this adding. Now, left hand side. Left hand side, dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square. Now what happened? See, when I'm adding these all values, see, we don't want to add and we don't want to waste our time. We'll use the trick here. What? Look at the first term is common for all. Even the denominator is common for all, correct?
Yes, sir.
Which is equal to minus of x square plus y square plus z square all to the power of minus 3 by 2 is common for all. And moreover, denominator is common for all. X square plus y square plus z square.
Yes, sir.
What's the first and the second and third I'm adding? Look at y square plus z square minus 2x square plus x square plus z square minus 2y square plus x square plus y square minus 2z square. We're getting the same thing now? Yeah, no?
Yes, sir.
Look at that. What is now? What happened now? Look at yes, minus 2x square plus 2x square cancelling. Y square 2 times positive and with negative terms. Z square 2 positive and 2 negative terms. 0 into anything is 0. 0 by any number is 0. Your answer will be 0. That's proof. Got it? You want to see the problem from the
Yes,
beginning? Do you have
yes,
any
sir.
doubt?
Once I'll
Just give me 1 minute and you see there. And after that, if you don't have any doubt, we can move to the next question.
okay, sir.
Please see each and every step carefully.
Yes, sir. No doubt.
So I'm moving to the next question.
Yes, sir.
Again, this is a tricky question.
No doubt.
Look at that. Second question of this or today's discussion, important question again. If x to the power of x, y to the power of y, z to the power of z is equal to e, then show that at x is equal to y is equal to z, the answer will be dou square z by dou x into dou y. Same questions, point to point questions you will get in your syllabus and your exam also. Point to point question. Minus of x log ex whole to the power of -1. Okay, अच्छे से देख लीजिए क्वेश्चन,
Yes,
right?
sir. Yes, sir.
Okay, we start the solution. So what is given?
x into y into z is equals to e, and dou square
X
v by
power
dou
x,
x.
y power y, z power z is equal
Yes,
to e.
yes, sir.
Our given condition is x to the power of x, y to the power of y, z to the power of z is equal to e. Taking log on both sides. Okay, we have to prove log. So take log. Log of x to the power of x, y to the, we are doing log answer. Z to the power of z is equal to log e. So it is of the form log a into b into c. We write it as log a plus log b plus log c is equals to log e values. Of course, it is 1. And again, log x to the
Yes,
power
sir.
of n formula is n log x plus here also n log y, that is y log y,
Yes, sir.
plus this is z log z is equal to 1. So what we do, we have to make it z as a subject. So keep it z here only, and rest of the value you can bring that side. It means z log z is equals to 1 minus x log x minus y log y. Okay. So this one we have to differentiate partially with respect to x. First with respect to x, then with respect to. So this one we call it as equation number 1. Now differentiate 1 with respect to x partially. Okay, with respect to x partially. I'm using the word only p here. P stands for partial. So when with respect to x we are doing now, look at that, z is also a function of x and y. We don't consider z
Yes,
as
sir.
a constant. Why? Because we have to differentiate z only with respect to x and y. So we can't say that z itself is a constant term. Z is a function of x and y. So here for this special for the z, we use uv formula for this one, u and v. So let us start.
Okay.
First function as it is, dou by dou x of log z plus log z as it is, dou by dou x of z again is equals to 1 is a constant, 0, no need to write, minus. For this and this again we have to apply uv rule. First function log x. Okay, let me write in detail. Dou by dou x of log x plus log x into dou by dou x of x. Close the bracket. And minus, we don't have here any x function, so that is 0.
Yes, sir.
One thing is very important here. While differentiating equation number 1, we are treating z as a function of x because we want to differentiate the value of z partially with respect to x and y. So in that case, z is our main function. Okay, z is our main function. We can't say that z is a constant. Okay, understood?
Yes,
Z as it is. Log z is 1 by z
yes, sir.
into inner function, that is dou by dou x of z as it is plus log z as it is again, and this also as it is. We are unable to simplify this one, so as it is, minus of x into, with respect to x, log x becomes 1 by x, inner function again 1 only, plus log x into this value is also 1. So we can stop it here only. And now look at what cancel here. Z with Z, X and with X cancel. Understand? So
Sir, I
whatever
have a
left
doubt.
here. Yeah.
Over
Good.
here is Z1. How do you get Z1 by Z, dou Z by dou X?
Okay, very good question. That will be clear here. Here, look at. I'll ask you a simple question. What is d by dx of log x? Can you tell me the answer of this? It is
1 by X.
1 by x, and please do not forget to write the inner function. But I said this one in so many cases. This value is 1 we are neglecting. If I ask you the same question for log y, what will be your answer? It will be 1 by y, okay, and d by dx of y as it is. Understand?
Okay,
Because
sir.
you see variable has been changed here. Here x is there, here y is
Yes,
there.
sir.
The same story, here x is there, here z is there. Log का जो भी differentiation है वो 1 by form में आ जाएगा as it is. But that should be an inner
Yes, sir.
function. If it is 1, if it is same function, that a value is 1. If it is not the same function,
Yes.
how it is 1? Now what happened, what I am doing
Okay.
here is, from these two I am taking dou z by dou x as a common term from these two. And here
Okay.
minus of 1 plus log x as it is. Just see once this steps 1 minute.
Yes.
Got the idea?
Yes, sir.
I'll move to the next. What happened here is, if I'm taking dou z by dou x common here, left of term is 1 plus log z here into dou z by dou x is equals to minus of 1 plus log. If you want to see the previous page, this is the previous page. We are taking dou z by dou x common, 1 plus log z here left,
Yes.
1 plus log x here left. From this, what
Yes,
is the value of dou z by dou x? It is equal to minus of 1 plus log x divided by 1 plus log z. Is it correct?
Yes, sir.
See, I want to make it z as a subject finally, so z we got it. Got it?
Yeah. Yes, sir.
Now, look at the pattern again. Z here is the numerator, but z here in the denominator. Similarly, x is here in the denominator, x is in the numerator. With the help of this,
Yes.
I want to write the similarly. The value of dou z by dou y I want to write it. Can you tell me now? That is minus of. जो भी यहाँ
Minus of 1
डिनोमिनेटर में वो
plus
न्यूमरेटर में होता मीन्स
minus
1 plus
minus of 1 plus log y. Log y.
very good 1 plus log y divided
1
by
plus log x.
1 plus log z. And the same thing I want to ask you one small question. What happened if I am taking x, y, and z all are equal? Because in our question also it is given to take this condition. At x is equal to y is
Yes,
equal to
sir.
z. So x and y and z. Example I'll tell you here and I'll erase it later on. If it is numerator as it is, and denominator in place of z also, if I am writing log x, what happened? These two are cancelled. I'm getting my answer is minus 1 in both of the cases. Are you
Yes,
getting?
sir.
Yes.
Yes, sir.
So that is, I want to write the value when x is equal to y is equal to z, dou z by dou x value is equal to -1 and dou y by dou z value is also equal to -1. Correct?
Yes, sir.
And this equation, what till here we have done now? Yeah. This is any equation number 1 we have, yes. So this is equation number 2. This is taken as equation number 3. Now differentiate equation number 3 partially with respect to x again. Continue. Differentiate equation number 3 with respect to x partially. Get our answer is dou by dou x of, because with respect to x of which value? Equation number 3, dou z by dou y value. It is equal to,
Yes, sir.
okay, with respect to x, be careful. Okay, minus outside, dou by dou x of 1 plus log y divided by 1 plus log z. Correct? Now see what I said.
Yes, sir.
Y is a constant, means minus of 1 plus log x is a 1 plus log y is a purely constant term. It will come out
Yes.
once if I am differentiating with respect to x for this value. Because here z is not our
Yes.
constant term. Z is not a constant. Be careful. Here we should apply this formula and get the answer easily. This one for your convenience I am writing. D by dx of 1 by x is minus 1 by x square. It is 1 by x is minus 1 by x square here.
Okay, sir.
Dou square. See, we are reaching to our answer very soon. Dou x by dou y. And now what happened here is, you see, minus of 1 plus log y is a constant term, purely constant term, would be taken outside,
Yes.
and then derivative of the term 1 by x format. Can we get the answer like that? Minus 1 by x square. And I request you, don't forget to write the inner function. Every time you have to write the inner function. We are assuming this one as x, so 1 by x square, got it, into inner function, that is dou by dou x of 1 plus log z. Most of the students are not writing the inner function. That will be a wrong answer. They will get it. Minus into minus plus 1 plus log y divided by 1 plus log z whole square. Log z whole square. And now look at, derivative of constant is 0 and derivative of log z with respect to x is 1 by z into dou z by dou x again. Correct?
Yes, sir.
Now what happened if you use the restrictions at x is equal to y is equal to z? Okay, we are
Yes,
about to
sir.
get our answer. Look at that. Our answer should be in terms of x I want. So every value y and z should be also replaced with x only. मतलब जहां भी y है वहां भी x लगाएंगे, z की प्लेस पे भी x ही लगाएंगे. So क्या, what answer we are getting? 1 plus log x divided by 1 plus log x whole square. Okay,
1 by
into 1 by z also equal to x only, and dou z by dou x value here what is there? It is minus 1, so minus 1.
minus 1.
So one term with the square cancel it, minus as it is 1 by x into 1 plus log x 1 can be written as log e now. Log e value is 1, right? Minus of 1 by x as it is. Log a plus log b. Log ab. And if you brings to the
Sir, how
numerator,
did you get log e plus log x?
in place of 1, I am writing log e,
Okay, sir. Okay.
which is equal to minus. If you brings all these values to the numerator, we are getting dou square z by dou x into dou y. If you take every values to the numerator, we can also write it as
Yes.
x log ex whole to the power of
Yes, sir.
minus 1. And now you see this is the requirement, x log ex whole power minus. Yes, got it? Now starting from beginning you can
Yes,
see
sir.
that. शुरू से एक बार आप देख लीजिए अच्छे से.
Yes, sir. No doubt. No.
See in this page also. And please
Okay.
take it this problem in your notes. Very lengthy problem, very important problem. And I hope you'll get this question now. They will not change the values.
Yes, sir. Okay. I'll get the same question, sir.
Same question, point to point. No doubt?
No doubt, sir.
Okay. So we'll end up this meeting.
Okay. Thank you, sir.